Hi everyone, Miss B here, and we are looking at Unit 4, Lesson 4 of Illustrative Math, Algebra 1. So let's get started with this assignment. This is the cumulative practice problems. So we're going to match each equation with the description of the function that it represents. So our first function here is telling us that the function x takes x, multiplies it by 2, and then adds 4. So we're going to do the multiply part first. So x is considered our input, so we want to multiply our input by 2 and then add 4 to the result. So this is going to match up with number 3 right here. I'll make that line a little bit thicker just so it's easier to see. There we go. Okay, function g is taking this interior portion and going to do that first. So we do need to use order of operations here and add 4 to our input first and then multiply by 2. So with order of operations, either PEMDAS or GEMDAS, sometimes I've heard it referred to as GEMDAS with a G for grouped, but we're going to do what's inside our parentheses first. So this one, if we have to add the 4 and then multiply by 2, we are going to, that looks like this first option here to get the output, add 4 to the input, and then multiply that result by 2. For function h, this says our input is x, so 4 times x plus 2. So 4 times our input, we're going to do that first and then add 2. So multiply the input by 4 and then add 2 to the result is option 4 down here. And even though we only have one piece left to match, we're still going to check that it does work, because if we did one of the other ones incorrectly, this one would be incorrect as well. So if we're doing what's inside our parentheses first, we should be adding 2 and then multiplying that result by 4. And this one says to get the output, add 2 and then multiply by 4. So that is correct. And we would add this one up here. And also, just for clarity, I am going to put A, B, C, and D next to these. So for option 1, this is B. Or for part 1, this is B. Description 2 is matched with D. Description 3 is matched with A. And description 4 is matched with C. All right, let's move on to question 2. This gives us a function, P, and that represents the perimeter of a square when the side length is x. So we're going to complete this table. Now I know a square has 4 sides, and a square actually has 4 equal sides. So each of these would be x units long, which means I can either add those all together, or I can say that I can multiply it by 4. So if each side is 0, the function value is going to be 0, and that square wouldn't actually even exist. If each side was 1, I'm going to have 4, because I would have 1, 1, 1, and 1. Add it all up would make 4. If it was 2, and we add all those all up, we would get 8. And if it was 3, we would add them all up and get 12. And if it's 4, we'd add them all up and get 16. And 5, we would add them all up and get 20. And for 6, we would add them all up and get 24. Now, if we want to write an equation to represent that function, this is increasing by 4 each time, but it's also taking our input value and multiplying it by 4. So I'm going to say that for this one, I would say P of x is equal to 4x, or 4 times x. That's going to be my function. Now to sketch a graph here, we can actually just label all of our points and have 0, 0, 1 be 4, 2 be 8, 3 was at 12, and then 16, and then 20, and 24. And this does make a straight line because it's consistent. So there's my graph. Okay, let's move on to question 3. Functions f and a are defined by these equations. So function f here has 80, and then we're going to subtract 15 times whatever our input is. And a has 25, and we're going to add 10 times whatever the input is. So if it's asking us which has a greater value when x is 2.5, we can just actually find those values. So if we did f of 2.5, that would be 80 minus 15 times 2.5. So this value, we're just going to actually evaluate here. So we would do 80 minus, and then 15 times 2.5 is 37.5. And f of 2.5, we're going to subtract that. So we're going to do 80 minus 37.5. And this would give us 42.5. And we're going to evaluate a for this as well. So a at 2.5 is going to be 25 plus 10 times 2.5. So, oops, capital A, not lowercase. A of 2.5 is 25 plus 25, because that's what 10 times 2.5 is. So A of 2.5 would give us 50, which is what 25 plus 25 is. So which has the greater output value? That's function A. So I am going to say function A. And this is what I'm going to put a little box around and consider this to be my answer. But I'm showing my work for each of these. Now let's go to the backside, or the next question, for question 4. An equilateral triangle. So it's defining it here for us and saying it has 3 sides of equal length. The function p is going to give us the perimeter of an equilateral triangle when it has a side length of s. So this is my input. And if it gives something, that means the output is the perimeter, because it will give you the output values. So find p of 2. If I have 3 sides, this is kind of just like our square question from the front that had 4 equal sides. This has 3 equal sides. So you can either say that p of 2 is 2 plus 2 plus 2, or that it is 3 times 2. And both of those would give you 6. So for the first part, the output is 6. Find p of 10. I don't like to do the addition one, so I'm just going to say p of 10 is 3 times 10, which is 30. And for p of s, I'm just going to say that this is 3 times s. And that is actually my whole answer. That kind of looks like a 5, because sometimes I write my 5s a little funky. So let's make sure that says 3s. There we go. And so that would be my output value when the input is s. Now we're on to the challenge/review question section, and there are 2 of these questions. So we'll use this part here. This is about functions, so this is more of review. Imagine a situation where a person is using a garden hose to fill a child's pool. Think of 2 quantities that are related in this situation that can be seen as a function. And define the function using a statement of the form blank is a function of blank. Be sure to consider the units of measurement. So you may have an answer that is different from mine, especially when it comes to units of measurement. Um, but in general, I would say that we're going to have something be a function of time here. And I am going to write this whole sentence out, but I'm just kind of filling in for some ideas to help me figure this out. So if you're filling up a child's pool, you can either think about this in volume. So you could say maybe it's gallons that are in the pool, or it's depth. So I would maybe say, I'm going to use depth, or how deep the pool is, how much water is in there, right? So we can say depth of water. Now, I do have to be conscious of my units of measurement. So I am going to say, I'm going to say the water in inches is a function of time in, and I'm going to choose to use minutes here. It wouldn't make sense for me to use hours because hours, it's not going to take hours to fill a pool. And it's going to not make sense for me to use seconds because it's going to take at least a few minutes to probably fill this pool up as well. So if I'm labeling my axes, I need to know which one is my input and which one is my output. And for our statement here, we say that output was our function of input. And I know that input is my generally x values and my output is my y values. So for part B, if I am graphing this, I want to put time in minutes on the bottom. So I'm going to say time in minutes. And I can say water in inches for the side. Oops. Inches. There we go. Okay, so label my axes. I did that. Sketch a possible graph of the function. Be sure to label my axes. So I labeled them. I'm going to say if you're filling a pool, that as time goes by, you're going to have more water. So I'm going to say it's probably going to fill at a constant rate for a little bit. And then maybe the pool is full and it's going to taper off and be flat. Your graph, as long as it makes sense, does not have to look just like mine. This is my example, and because you may be using different units, you can use something other than water in inches or time in minutes. This was just my choice. So if we're identifying coordinates of one point on the graph to explain its meaning, I guess I should take some units here. So I'm going to just 1, 2, 3, 4. Maybe it only took 4, 5, 6, 7, 8. So maybe it only took 4 minutes to fill the whole pool. And this might be 1, 2, 3, 4, 5. Now, my water in inches, it's not going to make sense for me to use like 4 inches. So I might say that each of these is, if it's a child's pool, you might have 1 to 2 feet of water in there. So we're looking at maybe 12 to 16 inches. So 1, 2, 3, 4. Let's go by 3. So 3, oops, that's an eraser. I'm going to say that my units are 3, 6, 9, 12, and 15. So the point I'm going to choose for mine is a little bit off from the 4 here. So I'm going to move my tally mark. I meant to have 4 line up with this part here. So I'm going to use red to show what point I'm thinking of. So my graph is a sketch, so it might not be perfectly accurate, but I'm thinking of this here, so some of my lines are a little bit off. I'm going to label this point. I'm going to say this is 4, comma 12. And what this means, I'm going to write a sentence over here to the left and say, after filling the pool for 4 minutes, there is 12 inches of water. Now, again, I chose kind of some random numbers. Your job is to actually, make some sense out of your own equation. Mine is an example, but this is not the only correct answer for this. And that's it for question 5. We're kind of creating our own situation here, labeling and interpreting our context. For question 6, the last question, this one gives the cost in dollars of buying n number of apples. So what I am reading from them is that if it gives the cost in dollars, that's my output, and then of buying n apples, that should be my input. So which statement best represents the meaning of C of 10 equals 9? Well, I know the number that goes right inside my parentheses there is the input value, and then this here should be my output value. So if I was not looking at my options, this would read to me in English words, the cost of 10 apples is $9. And let's look at our options. So our first option is just the cost of buying 9 apples. Well, we're not buying 9 apples, we're buying 10. So it's not this one. The cost of 9 apples is $10. Not quite, that has our numbers switched around. The cost of 10 apples is $9, so it's not B either. The cost of 10 apples. Well, we are talking about the cost of 10 apples, but we're saying that it's a specific dollar amount. So the cost of 10 apples would just be if we said C of 10 on its own. But this is an equation, so we have equal to a value. So it's also not choice C, which means it is D, that 10 apples cost $9. And that is it. We don't have any more for this assignment, so that was Unit 4, Lesson 4 of Illustrative Math, Algebra 1.